Now, here's a typical question that you might be asked about the binomial distribution, and it's what are the 5 conditions needed for a random variable x to follow a binomial distribution. And I'll just start by writing, representing x, how you'll see it written and how you'll need to write it. So x is some random variable, and this means represented by the b for binomial distribution, and it's the number of trials n and the probability of success p. Now, what are the conditions for the binomial distribution to take place? Now, the first one is that there must be a fixed number of trials. That just means that this number of trials here must stay the same. So let's think of a scenario. Let's say that this is the number of tails we get when we flip a coin, and this is how many times we flip the coin. Let's say we flip it 10 times, and this is the probability. If it's a fair coin, it will be a half. So we flip the coin 10 times, and what the binomial distribution will do is predict how many tails we get. So there must be a fixed number of trials, so we've given that there as 10. And the next thing that must be satisfied is that the probability of success in each trial must remain the same. So like we have here, the probability of success is 0.5. That must stay at 0.5 for the entire thing. The first two are quite similar. The next one is that all trials are independent. Let's think about what that means. So let's go back to this scenario. If I flip a coin and get a tails, rubbish at drawing, so I'm just going to write on the outcome, tails, and let's say next time I flip it, I get a heads. Now, the fact that I got a heads the next time had nothing to do with what I got the previous time. It didn't matter what this was. The outcome of this was totally independent, it had nothing to do with this. So these two are independent, and that's what this means. So the next time you do a trial, it must have nothing to do with the previous time. Okay, now the next next condition is that the outcome for each trial is either success or fail. Now in this scenario, when we're looking for the number of tails, this would be a success and this would be a fail. So you can only have 2 outcomes. You either get what you want or you don't. And the last one is that the random variable x is the total number of trials. So it just means, like we said here, it's the number of tails. We defined tails as being a success. So in the next part of the video, we're going to try a question involving the binomial distribution. Right, here's the practice question part of it. Now you'll notice it's really wordy. You're probably thinking, oh, do I have to read all this? But this is the reality of the exam, is that they will give you really wordy situations, and you've just got to read it carefully and pick out the important information. Alice places 15 randomly selected grapes in each of her punnets. So here's a punnet, and she's picking the grapes and putting it into one of these plastic tubs. Based on the season, the farmer tells her that 35% of the grapes in the orchard will not be ripe yet, while the remainder of the grapes will be ready. After having picked the grapes, Alice counts how many are not ripe yet. And the question says, find the probability that a randomly selected punnet has exactly 5 grapes that are not ripe yet. The first thing to do is to define our binomial distribution. So the form is like this, and we've got to think about each of our particular one. So we would have the number of trials would be how many grapes she picks, and it's 15. The probability would be what we're given in the question. We just change that into a decimal, 0.35. But importantly, this is the probability of success, and this is defined as the amount of grapes that are not ripe. Therefore, this will be the number of grapes that are not ripe. The number of grapes which aren't ripe. Okay. And now for the next bit, we have to turn to our calculator. So we want to work out the probability that the number of grapes that aren't ripe is equal to 5. And how we do this is we get up our calculator. Now hopefully you've all got this calculator. It's a ClassWiz calculator. If not, you need to buy it for the A-level exams. And what you do is you go on menu, number 7, which is distribution, and we want binomial PD. You always want PD if it's equal to. If you're finding less than or equal to, you'll want CD. We'll do that next. So binomial PD, press 4 and press 2. So we want our x to be 5, the number of grapes she picks is 15, and the probability of an unripe grape is 0.35. So press equals, and there we've got our answer. It's 0.212 to 3 decimal places. For the next question, we're asked to find the probability that a randomly selected punnet contains more grapes that are not ripe than ones that are ripe. So we need to think about, if we've got 15 grapes, we're going to have ones that are not ripe and ones that are ripe. Now for there to be more of this, we could have 8 of these and 7 of those. We could have 9 of these and 6 of these. Remember, we're splitting 15 because she picks 15 per punnet, or 10 of these and 5 of these, 11 of these, 4 of these, 12 and 3 of these, 13 and 2 of these, 14 and 1 of those, and 15 and no grapes that are ripe. We couldn't have any less than this, because if we only had 7 grapes that are not ripe, we'd then have 8 ripe grapes, so there'd be more. So we don't want that scenario. So I'm going to remove that because we don't want it. Okay, so we want the number of grapes that are not ripe. So remember, we represent this like that. We want the number of grapes that are not ripe to be greater than or equal to 8. Now, our calculator can only find things of the form less than or equal to some number. So we have to convert this into that form. Now there's a formula that you need to remember, which says that the probability of x is greater than or equal to a is equal to 1 minus the probability of x is less than or equal to a minus 1. So we're going to use this formula now. The probability of x is greater than or equal to 8. So a is 8. It's going to be 1 minus the probability of x is less than or equal to. As a is 8, I could just replace that with 8. So 8 take away 1 would put 7 here. Now our calculator can work this out. So let's get back to our calculator. So we go back to menu 7, and this time, because we've got a less than or equal to, we want CD, binomial CD. So click on that, press variable again, and this time we want 7. Everything else stays the same, still the same number of trials, still the same probability, press equals, and but we're not done because we need to do 1 minus this answer. So our calculator will save it for us. We just go menu back to 1, press 1 minus ans. So there's our answer. So this is the probability of finding a punnet that has more grapes that are not ripe than ripe ones.